Hello everyone, welcome back to Ma'am Balot's math tutorial. Today we will be discussing the different measures of position. The first measure of position are the quartiles. These are the three score points which divide a distribution into four equal parts. If that is our distribution divided into four equal parts, the arrows there signify the quartiles, which are the first one is what we call the first quartile, denoted by Q sub 1. In this point, it means that there are 25% of the data which are below the first quartile. And we also call the first quartile as the lower quartile. The second one is the second quartile, or the Q sub 2. So in this point, 50% of the distribution are below to this point. So the second quartile can also be called the median. And then the last one is the third quartile, or Q sub 3. So there are 75% of the distribution that are below the third quartile. And the third quartile can be also called as the upper quartile. So you have to take note that first quartile is less than the second quartile, which is also less than the third quartile. That means that the second quartile is less than the third, but of course greater than the first quartile. Now, how do we compute the quartiles for ungrouped data? In here, we will be using the Mendenhall and Sinsich method. So the steps are, first is you have to arrange the data in ascending order. Then you calculate n, which is the position of the kth quartile, or Q sub k, which has the formula of k over 4 times n plus 1, where n is the number of elements and k is the kth quartile. The next is to round the result to the nearest integer. Then, if n falls halfway between two integers, that means you have a decimal point of 0.5. So you have to round up for the lower quartile and round down for upper quartile. So the nth element that is computed is now what we call the kth quartile, or the Q sub k. So let's have an example. A group of students obtained the following scores in their math quiz. We have 8, 2, 5, 4, 8, 5, 7, 1, 3, 6, 9, 2, 7, 6, 9, 6, and 8. Find the first quartile, the third quartile, and the interquartile range. So the first thing that we need to do is to compute for the first quartile. So following the steps, we have now arranged the scores in ascending order. So the scores now are arranged from 1 up to 9. The next is we need to compute for n, or the position of Q sub k. So since we will be computing for Q sub 1, or the first quartile, so our k there would be 1. So we have now n is the position of Q sub 1. So substituting to our formula, we have now, instead of k over 4, we have now 1/4 times n is 17, because we have 17 ungroup data. So you have now 17 plus 1. So 17 plus 1 is 18. Then 1/4 times 18 is equal to 4.5. Now observe that the position of Q sub 1 falls halfway because we have a decimal point of 2.5. Since we will be computing for the lower quartile, so following our steps, we need to round up the value of n. So since n is equal to 4.5, that becomes now equal to 5. And from our arranged data, we can now locate the fifth data, which is 4. So our first quartile is equal to 4. Then we compute now for the third quartile. So following the steps, we have already arranged our data. So we will go directly in solving for n, which is the position of the third quartile. So since our k now is equal to 3, so substituting to the formula, we have now 3/4 times 17 plus 1. So 17 plus 1 is equal to 18. And then 3/4 times 18 is equal to 13.5. Since 13.5 also falls halfway, then we have to round down because we will be computing for the upper quartile, which is the q sub 3. Thus, our n now is equal to 13. So we will now locate the 13th data in our arranged data, and that is now the value of 8, which is colored there in red. So our third quartile is equal to 8. Now we have to compute for the interquartile range. So this is computed as the difference of the third quartile and the first quartile. So we have IQR, which is the interquartile range, is equal to Q sub 3 minus Q sub 1. So we substitute the value of our quartiles. We have Q sub 3 is equal to 8 minus Q sub 1 is equal to 4. So our IQR is equal to 4. What is now a linear interpolation? It is a method of curve fitting using linear polynomials to construct new data points within the range of a discrete set of known data points. It is useful when we are looking for a value between the given data points. So how do we do the linear interpolation? So we have here the different steps. First is you have to get the positive difference of the data where the interpolation is needed. Next is to multiply the result to the decimal part obtained in computing for n in the position of the q sub k. And then, we have to add the result to the smaller number where the interpolation takes place. And that would be now the result of our q sub k. So let's have an example. Example 2. A group of students spent the following hours in social media in a day. We have 82548571362766. Find q sub 1, q sub 3, and the interquartile range, and do the linear interpolation. So again, we follow the steps in computing for the quartiles. So in computing now for the first quartile, we need to arrange the data in ascending order. Then we need to compute for n, for the position of q sub 1. So we have now 1/4 times, since we have 14 data, so we have n is equal to 14. So you have there 14 plus 1, which is equal to 15. And then 1/4 times 15 is equal to 3.75. So what we need to do in the interpolation is, we need not to round off the decimal point in our n. So we need to locate the exact location using the linear interpolation. We will now use the steps of the linear interpolation, which is, first, get the positive difference of the data where the interpolation is needed. From our arranged data, since our n is equal to 3.5, so the interpolation is needed between the third and the fourth data, which are there colored in red, which are 2 and 3. So the next step is you have to subtract. So we have 3 minus 2 is equal to 1. Then we multiply the result to the decimal part obtained in computing for n in the position of the q sub k. So our n is 3.75. So the decimal part is 0.75. So we will multiply this one to the result of the previous step, which is 1. So we have 1 times 0.75 is equal to 0.75. Then the next step is add the result to the smaller number where the interpolation takes place. So the result is 0.75, and we need to add this one to the smaller number there. So between 2 and 3, so we have 2. So that becomes now 0.75 plus 2 is equal to 2.75. Thus, our q sub 1, or the first quartile, is equal to 2.75. Now we compute for the third quartile. So we then arrange and then compute for n. So since we are computing for q sub 3, our k now is equal to 3. So we have 3/4 times 14 plus 1, which is equal to 3/4 times 15, which is equal to 11.25. So we will now do again the steps of linear interpolation. So first is get the positive difference where the interpolation is needed. So since we get a value of 11.25, so the interpolation will take place in the 11th and 12th data. So are both 7. So we need to get the difference of them, which are 7 minus 7 is equal to 0. Next is to multiply this result to the decimal part of n. And since our n is 11.25, so the decimal part is 0.25. So multiply this one to the positive difference, which is 0. So we have 0 times 0.25 is also equal to 0. The next is add to the smaller number. So since they are both 7, so we have 0 plus 7 is equal to 7. So our third quartile is equal to 7. So actually, if the positive difference is 0, or you need to take the interpolation between two the same number, so you need not to take part of the other steps anymore. So automatically, you can have the value of the q sub k on that data. So computing now for our QR, we have 7 minus 2.75 is equal now to 4.25. So the interquartile range is 4.25. Now let's have the deciles. Deciles are the 9 score points which divide a distribution into 10 equal parts. So it has the same concept with the quartiles, but the only difference is quartiles divide the distribution into 4 equal parts, while deciles divide the distribution into 10 equal parts. So if these are the distribution divided into 10 equal parts, so we have here the different deciles, which are denoted by the first decile is d sub 1, second decile is d sub 2, and so on until d sub 9, which is the 9th decile. So in the first decile, there are 10% of the distribution that are below to this point. Then, in the second decile, we have 20% of the distribution as below it, and so on. Then, for d sub 5 is the median. So, this is also equal for the second quartile. So, and so on until we have d sub 9, we have the 90% of the distribution are below to this point. Now, how do we compute for the deciles of ungrouped data? So we have almost the same steps in our quartiles. So first is arrange the data in ascending order. The next is calculate for n for the position of d sub k. So the only difference there in the formula of the quartiles is the value of the denominator. So we have here k over 10 instead of k over 4. So in quartile, since we divide the distribution into 4 equal parts, so that is why our denominator is 4. But in decile, since we divide the distribution into 10 equal parts, so that is why our denominator here is 10. So it is the same that n is the number of elements and k is the kth decile. So after that, we need to round the result to the nearest integer, and then the nth element now is the kth decile. Now let's have an example. Using the same data that we have in example 2, we will find the value of the third decile and the 6th decile. So compute now for d sub 3. So first is again we need to arrange the scores in ascending order. Then we compute now for n. So since we are computing for the third decile, so we have n is the position of d sub 3. So since our k is equal to 3, so we have the formula 3 over 10 times 14 plus 1 since our n is equal to 14. So that becomes now 3 over 10 times 15. So it is equal to 4.5. So in our steps, we need to round off the nearest integer. So we have now n is equal to 0.5. So locating now the fifth data from our arranged data, and that is now equal to 4. So our d sub 3 is equal to 4. Next is to compute for d sub 6. So since it is already arranged in ascending order, so we need to compute for the position of d sub 6. So k is equal to 6 here, so we have now 6 over 10 times 14 plus 1. So that would be 6 over 10 times 15, which is equal to 9. So since it is a whole number, we need not to round off this one. So we will locate now the ninth data in our arranged data, and that is the data there colored in red, which is 6. So our sixth decile is equal to 6. Now let's have the percentiles. If the quartiles divide the distribution into 4 equal parts, the deciles into 10 equal parts, the percentiles divide the distribution into 100 equal parts. So the percentiles now are the 99 score points, which divide a distribution into 100 equal parts. So if we will relate the value of percentiles to the quartiles, so the first quartile is equal now to the 25th percentile. The second quartile is equal to the 50th percentile. So which means 50% of the data are below it and 50% are also above it. And then the third quartile is equal to the 75th percentile. And if we compare it to the different value of our deciles, so d sub 1 is equal now to the 10th percentile. D sub 2 is the 20th percentile. D sub 3 is the 30th percentile. And so on and so forth until d sub 9 is equal to 90th percentile. To compute for the percentiles for ungrouped data, again, it has the same steps in computing for the quartiles and deciles, but the only difference there is in computing for n, which is in our quartiles, again, the denominator is 4. In deciles, the denominator is 10, while in percentiles, the denominator is 100. So let's have an example. Example 4. In the same data that we have, compute for the 80th percentile. So we need to arrange the data in ascending order, and then we compute for n. So since we are computing for p sub 80, so n is the position of the 80th percentile. So our k is equal to 80. Substitute to the formula, we have now 80 over 100 times 14 plus 1. So that is 80 over 100 times 15, which is equal to 12. So we will now locate the 12 data in our arranged data, and that is they're boxed in red. So our 80th percentile is equal now to 7. Now it's your turn to answer your activity learning sheets. I hope you learned something from our discussion today. But please don't forget to like and subscribe. Thank you so much for listening. At your service, Ma'am Balot.